Okay, so there's really not much we need to change here. The flow of data is going to be the same. The overall use case is going to be the same. So all we really have to change is up here in the state transition. And from here over, all happens in the background. So that's going to be exactly the same. So the only thing we're changing is this box right here. Grabbed an orange piece of chalk. Hopefully this will show up. So the only thing that's really changing is instead of going to the menu state, we need to go to an interface state, which will have a couple things. So I'll come down here and just kind of add it in. So the first thing we have to do is draw that. We have to draw the interface on the screen. So we'll go to a drawing state. And then, well, we're going to draw some rectangles that we'll call buttons. So that if the user clicks inside there, we'll say, okay, that button has been clicked, and then we'll know which one to go on. So all that's included in the draw state. Then after we draw it, we have to just wait for that event to happen. So that'll give us, we'll call that a listen state. And then we're going to listen until the user clicks on one of those buttons. And then at that point, we'll either come to our show state, our create state, or exit state. So that's the only thing we have to change. Then afterwards, after we're finished, these loops will come back around. Well, the output, I guess, will be a little bit different because we're going to draw that on the screen. So I could write draw instead of sending it to the console, draw the new output. But then when we're ready for the next run, we'll kind of clear that out. So we'll come back around. And, well, maybe we don't need to come to the draw state. So instead of coming back around to the draw state, because if we have some output, if we print our output on the GUI, well, then the buttons are still going to be there and everything. So we can come back around to our listen state and just keep repeating until the user selects the exit option. So that's all we need to change on that. Okay, so there's still one piece of knowledge that we haven't gone over in order to make these just a couple of changes. And that's how can we tell where the user clicks? I kind of ran out of room, so after I erase some stuff, I'll erase the use case. So remember, a use case diagram is just shows our user or maybe multiple users as a stick man, and then a bubble representing the software or device or whatever IT thing we're working in. So I'll erase this and put up some information about a button. Button click. So essentially, what we're going to call a button is just a picture of a button. For us, we're just going to draw a little box, a rectangle. And we've talked about it before. You might remember that in order to draw a box or a rectangle, we just need 2 points, two opposite corners to define the point. So I'm going to call this X1, Y1 will be this point, and this point will be X2, Y2. So we have those 2 points. And you might remember from graphing that, like X, that's a number on our axis, right? So we have X1 here on the axis. So really that X1 is a huge vertical line there that continues on past just the box we drew. That X value continues up and down the entire way. Same thing for our other X value and our Y values. So we can use those 4 points to tell if we're inside of this. Well, first thing we'll check and see if we're bigger than X1. That means we're to the right or to the right of the left edge of the button. So if our click X value is bigger than x1, well, that means we've gone everything this way. The user's going to click somewhere, the computer's going to notice where they click, give us the x and y value of that. So if it's bigger than our x1 value, that means everything this way. But we also want to be smaller than our x2. So then we'll also check if click x is less than x2. Well, that'll be everything from the right side to the leftward. But if we do and, so in an and condition, our logical operator that means both of those have to be true, then if we're to the right of this x value and to the left of this x value, the only place we could be is in the width of that box. Then we can do the same thing for the y's. So, and our click y, and remember Raptor starts in the lower left-hand corner, and x goes up this way and y goes up this way. So if the click is somewhere smaller than y1, that means we're everything below this line. So if it's smaller than y1 and that click y is bigger than y2, which is the y2, so if it's bigger than that, and smaller than that, the only thing it could be is this little strip here that our button's included in. So if we have all four of those conditions, if it meets all four of those conditions, then the only spot that would meet all four of them is on that button. So that's how we can tell if a button has been clicked and use event-driven things rather than menu-driven things. It seems a whole lot more modern. Yeah, let's go look at this in an example. We'll draw the GUI, put some rectangles there, call them buttons, and we'll store those coordinates for the corners in variables so that we can check this condition every time and see if we're in there or not. Okay, so real quick before we start doing that example, I'm just going to jot out a quick picture of it. I'm still out of room, so I'm going to erase the data flow diagram. So remember, a UML data flow diagram just shows how our data flows through the diagram, through the program. And we often have to use more than one UML diagram because no single one conveys all of the information. I had a piece of chalk somewhere. So we need to come up with an idea of what our interface is going to look like. So what I'm thinking is what was in our original menu, we'll just copy that and put it somewhere up near the top. Or well, we don't even have to copy that. The instructions are going to be on the buttons, right? This is the main thing I want to talk about. Because we're going to save the points for every button, those coordinates, into variables. So to minimize that, we can line things up. Like, I think I'll just come down the side and put the buttons here. Like, there's one of the buttons. There's one of the buttons. And there's one of the buttons. That way we have the same X coordinates for the buttons all the way through. And we don't have to create separate X and Y variables for all of them. We'll have the same X coordinates on all the buttons. So it'll be like button X1 and button X2. And we just have two to kind of cut down how many we have. We'll print our output down here. Have a spot to put output and maybe some sort of prompt. I don't know if we really need a prompt. But just a layout like that. Just a quick sketch of what the layout's going to look like. So now let's go put all this together and modify that previous program so that instead of showing them a menu, we show them an interface like this, and then the user can click on the buttons instead of typing in an option.
So the first expansion I want to do on this program is menu-driven programming seems it kind of feels out of date, right? We use the mouse and keyboard, and in modern times we do almost exclusively what's known as event-driven programming. We want an event to happen, something happens, like the user clicks on a mouse or the user presses a button on the keyboard. Those are events. So they require a graphical user interface, or a GUI. So let's move this from a menu-driven program over to an event-driven program, a very simple version. The first thing, I'm going to open a new Raptor file to do that. But something that I believe I've stated it before, and it's kind of shows up here, right? So notice how if we try to take this whole program as one thing, that's kind of overwhelming, right? We split it up to 3 different subcharts, which are all larger than shows on the screen on their own. And there's a lot going on. So with programming, you never want to try to take the whole thing at once, in one line at a time. Just deal with it in little bitty pieces. That's what the word analyze means. Break it down into pieces. And don't deal with the entire program. Deal with one line at a time. And when every single line works correctly, then the program will work correctly. Just wanted to make sure and explicitly state that. So let's move this over to a graphical user interface, and so we can do some event-driven programming, make it seem a little more modern. But the first thing is probably want to test that along the way, and there's a lot going on here. So I'm going to create a new Raptor file. Yes, save the current state. And then I'll copy, then once we get the interface going, because really the interface is just going to sit on top of that thing we just did. So I'm going to create that separately and then copy and paste it back over there. That way we can test it along the way. So we've seen some of these things. Just to get a graph window going, we bring in a call box and we'll say open graph window. And then we need the height that we're going to open it. So I don't know, I'll start with 500 wide and 700 tall. Let's see what that looks like. We run that. That'll give us a window about that big. Can make it a little smaller. I'll do 500 by 500. That'll work. I have this nice little window to work with. Then we can put some buttons here, which are really just pictures of buttons. Pictures on the screen that we're going to pretend are buttons, and we'll call them buttons that the user can click on to make one of those 3 things happen. So we'll want 3 buttons there. So we have some pre-built functions for the graphics. One of those being draw box. So if we start typing draw, you can see on here is draw box. Or if you wanted, you could bring in a nice picture of a button. But for us here, the example, let's just bring in a box. So we need some X values and some Y values. So I'm going to start this. I'll put some numbers in here. So say it starts 350 over and 400 up. And then it's going to go until 450 over and 350 up. 350 up. So the box will be 100 pixels wide from the X to the X and 50 pixels tall from the Y to the Y. And then we need to say what color it's going to be. So I'm going to make this, I'll just do red, green, and blue boxes. I'll make this one red. Oh, and then yes, fill that box in is the last argument. So yes, it's going to be filled in like a solid color, and no, it would just be the outline. So we'll run that. That'll look like a good position. I'll put a red box here, and a green box, and a blue box, and then that'll be the ones we want to type on. But probably want some labels there, and what we talked about on the board, we want those X and Y values in variables so we can check things against them. So let's throw those in variables. So I'll put the X values into variables. So, oh, I forgot to save it. And this is just a scrap one. This is just to test a small piece. And then once that small piece works, I'm going to move that over into the actual program. So let's say button X1 was at, from that test value, that was at 350. It's at 350. And then we'll have another variable called button X2, which is at 450. So that saves our X values there, those side ones. So then if we stack our buttons up, kind of like what the flowchart looks like here, the X value would be the same on every button. So we don't need variables for those. But we do need some variables for our buttons. So let's move those Y coordinates over there as well. So the first button, I guess, will be option 1, like the menu. So that'll be a show button. So we'll call it show_Y. And that's going to be our first Y value. Show Y1, because we'll need 2. So the show button, Y1 value would be 400. And then another assignment, and we'll have a show button for Y2 value, and that will be 350. So that gets our X and Y values there. So instead of drawing the box at these numbers, we want to use those variables. So we have button X1, and then show Y1, button X2, and show Y2. So really the same thing, it's just we stored those numbers in variables to make it easier to refer to them later or to update them. But it still looks the same. You might want some words on there as well. So after we draw that button, let's come over here and draw some text on top of it. So then we can call that pre-built function for display text, and we're going to put that inside the button. So we'll come to the X value, which would be button X1, and then plus, so maybe 15 pixels, and then a Y value, so the show Y1 has that same number we put the box at, but let's come 15 pixels down from that to start it, maybe 20 pixels down to start it. So just a slight, just a little bit off from the corner of the button will start some text. And then this text will say show. Whoops. And that needs to be a string. So show addresses. And a color, well, the box is red, so I'll just make this white. Let's see if that works. Yeah, that'll work. It kind of cuts off the word, but y'all can mess around with that and see if you can get that to fit in there. I'll just go with it as it is for the example. You can just modify those numbers slightly. And that's often what happens. You try something, see where it is, and then make little adjustments until it gets to where you actually want it to be. But I think you can see this is going to get kind of cluttered fairly quickly. So maybe we can move this over to its own subchart. So I'm going to make a new subchart here called show button. And this stuff that is for the show button in particular, I'm going to cut that and move it over here, and then replace it over here with a call to that subchart. So it should still run the same. Yep, just brings that up, and yeah, if you just play around with that a little, you can adjust the size, make the words look nice in there, but that kind of gives us our first button. And really we need to do that 2 more times. And both times are pretty much just going to be a copy of that, a slightly modified copy. So this button was 50 pixels tall, so all I'm going to do to modify it is I'm just going to add maybe 80 pixels. So come down here somewhere, come add 80 pixels to it, and then change the color and the label for the create button, then add 80 pixels again so it'll be more than the 50 tall it is, and change the color and the label for the exit button. So I'll go ahead and bring in call statements and create those subcharts. So one subchart called create button. You gotta go ahead and create that. And make in the main another subchart called exit button. And create that. And then those are basically going to be copies of this. So I'm going to take this here in the show button, Control C to copy everything, click where it goes, and Control V to paste it. And same thing over here, Control V to paste it. So then these variables are going to be slightly different. So instead of the show button, now we're on create button. So we have create Y1. And I'm just going to come down 80 pixels. That button was 50 pixels tall. So if I come down 80 pixels, that'll be past it. And increase everything by 80 pixels vertically. Then create Y2. And 350 plus 80 would be 430. Then we're going to draw the button. Well, we changed the variables, so now instead of show Y1, we want to go to create Y1 and create Y2. And then I'll change that to be a blue button instead of a red one to help them stand out, and change the text, the label that shows on it, to say create addresses. So just a couple little modifications, and same thing for the exit button. So we're going to change this variable name to exit Y1, and our first button was at 400 pixels, so we come down 80 pixels to 480. Then another 80 pixels would be 560. And show Y2 now becomes exit Y2. 350 plus 80 is 430, plus another 80 is 510 pixels. Then when we go to draw the box, we want those other variables. We want exit Y1 and exit Y2. And we'll do a red and a blue one, so I guess do a green one. And then this label is going to be exit. So just keep copy and paste in mind, because we do very similar things 3 times. So with just a little bit of thought beforehand, we're able to set one button up and then just copy and paste that twice, and just a couple little changes should show all 3 buttons now. Uh-oh, something went wrong. Oh, forgot to change. So this display text is still looking at the show Y1 value. So we want that to be, which tab am I on? The create Y1. And exit button will be at exit Y1. And I think there was another problem. Yeah, I went the wrong way. Most of our programming things, the Y value goes down. It increases as we go down the screen. But Raptor goes up, and I accidentally did that. So I added 80 pixels when I should have been subtracting 80 pixels. So let's modify those. So here, 48, we started at 400, and subtract 20 would get us, or subtract 80 would get us down to 320. Then here, the original one was at 350. And we want to subtract 80, so we could do that, but computers can do math. We can just do 350 minus 80. I'm going to type that in as 270. Like, we don't have to actually solve the math. We can just type in the formula and the computer will have no problem with that. And the exit button, so our original one was at 400, and we want to subtract 80, and then subtract 80 again. So what would that be? 320 minus another 80 is 240. 240, and then this one started at 350. So 350 minus 80 gets us down to 270, minus 80 again would get us down to 190. Or we could type the math in. Let's see if that worked. All right, that worked a little bit better with what I was thinking. So now we have these 3 buttons we can click on, and could use a little bit of modification there, but this is just a quick example. So, gives us spots to click, which so far nothing happens. And then when we move it back over to the regular program, then we'll put some output over in this big white area whenever we show the addresses. But we need to click on those buttons now.